The behavior of infilled wall during an earthquake is also not well understood. During design, what we do is the weight of the wall is supposed to come on the beam as a dead weight, and that is what we consider in the analysis. But earthquake is about lateral forces that affect the frame and the wall, what we call infill, maybe a brick wall or any other wall, get affected during an earthquake. So if you see this picture, the cracks come along the joint between beam and column. This is one way of failure that is possible, what we call in-plane behavior. Here we have two roles in any infill wall. We have two roles. One is called in-plane behavior, another is out-of-plane behavior. We will understand slowly. But in-plane behavior failure will be only along the column or along the beam. So as you can see here, how this failure happened in these two examples that you are seeing here. Another possibility is, suppose if there is a wall and the lateral forces are coming at the top like this, so there is a kind of strut and tie action that can happen. So 1893 talks about this, and then they say how to take this. So we take this as a tie in the analysis to increase the stiffness role along with the strength role. This is the stiffness role. So this side also, if you take and understand that, maybe you can improve that design of this infill wall itself slightly better. Otherwise, you will have this kind of diagonal cracks like that. So this is also another behavior which is that of in infill wall. That you can see here this kind of inclined cracks that happen in these walls. So it's mainly because of the lateral force that is available in the top and the lateral reaction that is available at the bottom, and in between this will be like a shear resistance. So this is the behavior of an in-plane wall, what we call diagonal tension. So this can be solved only by assuming it is a certain type and then solve that problem. For example, if I have a simple house system, it is resting on foundation, you will have something called a door, or you will have something called windows in any of these walls, and there is a roof. But the understanding is mainly because earthquake is going to, let me say, it is going to be a lateral direction, and the wall B has actually pushed so that that is a possibly it is stopping. That is on one side. That is on one side. But the other side, in the same direction, because of the large resistance of the wall, where the depth is large. Actually, if you understand BDQ by 12, the depth is nothing but the length of the wall. So that is going to be large amount of resistance. So this wall is going to be little rigid comparatively by the other direction, where the wall B marked B is called weak direction. So in any, of course, earthquake is going to come in any direction. So if I take a building, there is something called weak direction where the whole wall may topple. So this is one possible failure. Uh, that is why you are getting the crack all along the length of the beam, all along the length or height of the wall, height of the column. So this is what happens in a case of failure. So generally, suppose A I take as in the direction of in-plane forces, B as take as an out-of-plane forces. So the B wall is going to tumble like that, because A wall is going to be likely rigid, because in the force direction there is very heavy area of wall is there. So in this case, suppose you want to avoid failure, the one of the way is that you introduce L-shaped double bar at these ends, so that they bind between A and B side wall, so that they can be saved if it is a masonry type of wall. And the another issue in this wall is, on one side you have the length of the wall also is matters. See, suppose along the direction of the wind, if there is a short wall, that behavior is something like rigid. But if it is long wall, there is possibly a bending also that happens. So that is why it is better not to have this large portion of wall unsupported. And of course, the normal way of taking care in such a masonry structure is, you will have a lintel beam here throughout the structural system. Suppose you have a lintel beam here, that will become as a tie everywhere, and that the action is slightly integrated, and that is slightly better. So that is the way it is. Otherwise, you have to consider this separately and understand this portion. And obviously, you have a door opening as well as a window opening in the wall. So considering this because of the in plane out of plane wall is also having an opening. Now it become little more weaker than the previous case. So that we have to take care. So how to take care is one way we is suppose we have uh, a larger window opening means that means it is going to reduce the wall strength. So it is better to have slightly smaller. So that is the way it is. So essentially, the wall plays a role in terms of lateral deformation that we have to understand thoroughly. And another interesting point is the way in which our staircase is connected. Suppose your staircase is connected at the ground floor and then middle floor and maybe at the first floor. This is the normal way that they do normally. But what is the problem is maybe assuming that the wall is taken care nicely with lintel beam or whatever, the joint is going to be a serious problem. And especially the wall here below the half floor, there is a short column effect. There it is a slender wall effect. So this is going to be there. And in addition to that, the joints are vulnerable because of the lateral motion that is also possible. So unless you take care of this joint much better, there is possibly a failure that is going to happen at this point. So if you really want to avoid that, maybe you can have a separate staircase, structurally separated, a small gap, so that structurally you can fill it also later. Constructively you can even fill it later. So that means the behavior of staircase is different from the behavior of house. So there is possibly a possibility of coming out of this issue uh, as such. So the in the masonry structural system, normally if you have issues like failure, as we can see here in this picture, one of the uh, solution is that you should have a plinth band, you should have a lintel band, and you should have a roof band. This is what normally recommended in the code book also. Suppose if you have that, you can have the best system actually, so that the lateral resistance system becomes slightly improved. And normally, this lintel beam is actually 150 by 230 or whatever. So we will have four rods and one stair stirrup. So, but suppose you want some something that not that big for a small span or something, like you can even go for 75 and 230 with only two rods and one this thing. It depends on how large or small your wall is, how large or small your wall is. So that is the issue that you can decide accordingly. So the main issue is assuming that there is a little band that is available, there is a roof band that is available, there is a plinth band that is available. Then there are issues like suppose you have large opening than normal. Suppose you have door opening and then two windows opening, and of course there is a criteria in code book that the opening should not be more than certain percentage. But suppose you have for that, so obviously the crushing will happen between in this wall where between openings. Suppose if the length is very small, so it will break. These are all the breaking points because of the lateral load. These are all the breaking points. If you want to still have that, the only way is otherwise you are likely to have this kind of X type of cracks because of the lateral shear that happens. This is kind of X type of crack will happen. So considering this, possibly if you want to avoid this, if you want to still have two windows and then if you want to have large windows or something like that, the only way solution is that you should have a vertical steel bar anchored to the foundation from bar foundation to the roof, like as it is shown here, between before the opening and after the opening, like that. Every opening you should have at least one rod should run through. So this kind of simple improvement reinforced masonry building, that is what they call it. So if you improve like that, then there is a possibility of this section also coming slightly better. So this masonry structural system needs this kind of improvement over the normal building. So this is what is called reinforced masonry. So that is you introduce reinforcement from the foundation to the top roof along the opening as well as in the end, and all openings. Suppose whether it is window or the more than one window, that also is a possibility. So otherwise, you are likely to have a crack like this. It will generate crack like this. So this crack is mainly due to one can identify that if you get a crack like this, it is due to lateral forces that are coming in the building during earthquake or whatever. So as I told, the only solution is that there is a roof band, there is a lintel band, and there is a sill band. Wherever necessary, you can put sill band also. It is similar to lintel band, but below the window it will be there. And for vertical improvement, you need a reinforcement before the opening as well as after the opening, and also both the ends. If you do like this, may possibly all the masonry walls can be taken care of nicely.